Section 4. MSA Application Deployment. In this section, we will try to deploy MSA application. Part 1. Deploying Redis and building database. First, run the installed Minikube using the podman driver and CRIO container runtime. Check whether Minikube was deployed normally by checking node and pod. It is deployed normally when the nodes are ready and the status are running as shown in the textbook. Download the MSA deployment setting file needed for MSA application deployment using the git command. Refer to the port numbering table shown to modify the variables when deploying. Here is an example on modifying the variable value. For the value of the MySQL MSA board variable in line 17, enter the corresponding value from the port number table, 30501. Enter the other variables in the same way. Now we will check the IP address of Minikube for external connections of service port. Modifying of Kubernetes setting file is needed for Redis deployment. We will have to modify the Redis MSA UI YAML file, and we have to modify the node port number into 30801 to allow external access. After modifying the Redis setting file, use kubectl command to deploy Redis. To be followed by modifying the YAML file for DB deployment. DB deploys MySQL and modify the Kubernetes configuration file for DB deployment with Vim editor commands respectively. Modify the node port numbers for accessing the node from the outside as shown. 30501 for boards, 30601 for comments, and 30701 for users. After modifying all the DB configuration files, use the following kubectl command to deploy the DB. Let's verify if the DB we deployed is running well. Run a kubectl command to view the pod. Then, connect to the pod with the second command to input DB data. To build the MySQL MSA board DB, connect to it with its name. Once you have access to the pod, log into MySQL using the commands in the textbook. From now on, we will enter boards, comments, and user-related DB data. Log into MySQL and create a board database. Next, create a table related to the board API. If you have completed creating board DB and table, as shown in the textbook, enter exit to exit each MySQL and pod. Next, let's access the comment DB. First, verify the name of the miscall MSA comment pad through the kubectl pod viewing command. You can access the MySQL MSA comment pod by checking the pod name and entering it in the appropriate second command. Log into MySQL when access to the DB. After logging into MySQL, create the DB for comment. Create table related to comment API. After creating DB and table of comment as shown in the textbook, enter exit to exit each MySQL and pod. Same goes for user DB. Check the MSA user pod name with the kubectl pod viewing command, then access to the miscall MSA user by replacing the pod name at the command. Log into the user pod using the command shown in the textbook. Log into MySQL, then create database. Then create user API related table. If you have completed creating database and table as shown in the textbook, exit miscall and pod by entering exit. The MySQL DB gets deleted when the VM gets restarted. Therefore, follow the procedure shown to rebuild the database. Part 2. Creating WAR file. Since the MSA application exercise project is developed with Java 1.8 version, you need to install JDK 8 version to configure the environment when you create it. You need an Oracle account to download JDK, so create an Oracle account first before proceeding with the download. Click the link below to download the JDK. When Consent to Oracle Licenses window appears, check and press the download button to proceed with the download, then proceed with the installation. After completing JDK installation, add environment variables to make the Java program accessible from anywhere in your local environment. Open System in Control panel and click Advanced System Settings to open the System Properties window. In the System Properties window, click Environment Variables. When Environment Variables window appears, click New to add the path to the JDK installation as a variable. In the New System Variable window, enter the variable name Java Home, and as the variable value, enter the path to the file where the JDK is installed. Click OK to confirm that Java Home has been added to the list of system variables. Next, click New one more time to set the path. Enter class path as the variable name, and library in the variable Java Home, which specifies the path where the JDK is installed, as the variable value. Press OK again to confirm that it was successfully added to the list of system variables. Specify the following path. Select path for the system variable, and click Edit. In the Edit Environment Variables window, click New to add the bin location of Java Home to the list, and then click the OK button. When you're done setting up the environment, click OK in the System Properties window to exit, and then open a CMD window to verify that the JDK is set up well. The installation verification checks the versions of Java and Java compiler by entering the command shown on the screen. If they both come up with a version of 1.8, you can confirm that the JDK 8 environment is set up well. The MSA API system used in this exercise is developed based on the e-Government Standard Framework 3.9.0 development environment based on Eclipse. To download the development environment, access the Standard Framework portal below. Download the eGov FrameDev 3.9.0 file from the download menu. After unzipping, run the Eclipse file inside the Eclipse folder. Next, let's download the API source. To build the WAR file, download the following 5 files: edumsa UI, edumsa Zool, edumsa user, edumsa comment, and edumsa board. They can be found by searching for edu-msa on the GitHub link in the textbook. Download the files and save them at the local source. Can be downloaded by cloning or download the zip file from GitHub. When the downloaded Eclipse is executed, you'll see the initial screen as shown in the textbook. To add a project file, click on the file, open project from File System in the top left menu. Next, you'll be asked if you want to import the project from a file system or an archive. So click the Directory button to select the API source file you downloaded. Then click the Finish button to load the project, and click the Finish button. Import all 5 downloaded files in the same way. Now let's prepare to generate the WAR file. All the edumsa board, comment, and user has API properties configuration files in the path shown. We will be modifying the API properties file. Since the 3 API sources, board, comment, and user are DB-specific APIs, you'll need to enter the variables found in the textbook for the MySQL MSA board, MySQL MSA comment, and MySQL MSA user variables, respectively, in your respective config files. You can enter 30501 for board, 30601 for comment, and 30701 for user. These variables can also be found in the port number table on page 53 of the textbook. Finish modifying the configuration file by entering default for the namespace variable in the second line and the minikube IP address for the Kubernetes URL variable on line 16. Now let's modify the edumsa UI configuration file. The API properties configuration file is located at the path shown in the textbook. Since the UI API source is a Redis-specific API, we need to modify the Redis MSA UI variable. In the Redis MSA UI variable on line 14, enter the port number 30801. You can also find this port number on page 53 in the book. Finish the modification by entering default in the namespace variable on the second line and the minikube IP address in the 13th Kubernetes URL variable. For edumsa Zool project, it builds directly into the WAR file without any modifications, because it applies variables from the YAML configuration file when deploying Kubernetes. Now, let's set up the Maven build to generate the WAR file. For Maven build, we need a Java execution tool, and Eclipse is basically a Java execution tool with Java runtime environment. That is, JRE is connected. However, there are frequent errors when Maven build with JRE, so we will change it to JDK, which includes JRE but also includes compiler and GVM etc. Required for programming. Select the window item in the top menu list of Eclipse, and click the preference item below. This will bring up the Preferences window. Select Java in the list on the left side of the window, and click the Install JRES item below. This will bring up a list of Install JRES on the right side. Select the checkbox and press Remove to delete them. After the deletion is complete, click the Add button on the right to add the JDK. Click the Add button, and the JRE type window will appear. Select the standard VM entry in the window, and click the Next button. Then click the Directory button in the JRE definition window. Browse to the path to the locally installed JDK file, and click the Finish button. When you return to the Install JREs window, you can see that the selected JDK file has been added to the list. Now click the Apply and Close button at the bottom to exit the application and window. Now let's build WAR file. Right-click above the name of the project you want to build, and the Select menu appears. Here, under Run As, click Maven Build to build the WAR file. If you click the item, you will see the Edit Configuration window, as shown in the textbook. In the middle of the Edit window, in the Goals entry, type Clean Install. When you click the Run button, it will automatically build the file. When build is completed, you can see the created file located at the target file for each project. Next is to move the WAR file we created to upload as a Docker file. First, run the MSA Xterm program. If you look on the left side of MSA Xterm, you will see a tab called SFTP. SFTP allows you to download and upload files. It allows us to move files from local to remote servers. If we go into the edu MSA file in the directory, we will find the configuration file for each project. And under it, there is a Docker file. Upload the WAR file in the target file path of each project built with Eclipse locally to the Docker file of each file through MSA Xterm's SFTP function. Once you've done that, you're ready to create the image. Part 3. Creating and deploying of image. Next is configuring a setup file for image creation. Edu MSA board, comment, UI, and user are Spring projects that contain server.xml, the Tomcat setting file, and the Docker file set for each project. Edu MSA Zool is a Spring Boot project that includes the setup file, the application YAML file, and the Docker file set for the project. This positioning of each WAR file completes the file preparation for image creation. Docker Hub is a Docker image storage service operated by Docker, and it is used as an image repository to create and push images. Docker Hub has over 100,000 container images from software vendors, open source projects, and communities. Now let's practice creating and deploying images with this Docker Hub. Create an account, then log into Docker Hub to create an image repository. Proceed to the repository page after logging in. Then click Create Repository at the right top of the page to create a repository. Input repository name, then click Create button. Create repository for each 5 projects in the same method as shown. When the image repository is ready, log in using the podman login command from the MSA Xterm terminal to allow repository access. Using the command at the textbook, build images of each of the 5 APIs using the files configured in the Docker file for each project. Tag the name of the image built with the name of the image you want to deploy using the podman tag command in the textbook. Do the same for all 5 APIs. When the image is ready at the local container storage, use podman push command to push the image to each repository on Docker Hub. The command shown at the textbook is a command to build, tag, and push board UI project. Refer to the command and process pushing the images. As follows for user and Zool project. Use the command to build, tag, and push the image. Once the image deployment to the image storage is complete, next we'll set up the Kubernetes YAML file so that the image can be deployed as a container. In the MSA board, comment, UI, and user YAML files, modify the parts that correspond to your image and the parts that correspond to your node port. It is differentiated as a blue text in the textbook. The picture shown at the textbook is an example of each project. After modification, make sure you have modified the YAML file properly. From the MSA ZUL YAML file, check whether the image, node port, and env namespace portion are modified as shown in the textbook. Compare it with the picture at the textbook to make it sure. When setting of each project of Kubernetes YAML file is completed, proceed to container deployment. Use the command shown at the textbook to deploy all the 5 YAML file. Once the deployment is complete, use kubectl get pods command to verify that the containers are deployed well. Next, we look up the services with the kubectl get services command to access the MSA UI screen on the node port. Once you have confirmed that your MSA application project is successfully deployed, through pod and service, access to the Firefox web browser on the VMware screen and try to use the service. To access the portal, enter the Minikube IP address, the node port number of the MSA UI, and the path shown on the screen to access the portal screen. When connected, check if the MSA service is working normally in the portal. After signing up and logging in, utilize the bulletin board and commenting features. This concludes Day 4, K-PaaS Exercise. Hope this 4-day expert training course has improved your understanding and ability to utilize K-PaaS. Thank you for your hard work.